The first Artemis mission has been launched. No, it wasn't the highly anticipated Artemis 1 Space Launch System rocket. Instead, it's a much smaller risk reduction mission designed to pave the way for the future Lunar Gateway, a small space station astronauts will use as a way station around the moon. This Pathfinder mission involves a small CubeSat called Capstone, and it will verify a special orbit and prove out a new navigation technique for future deep space spacecraft. Capstone is an acronym for Cislunar Autonomous Positioning System Technology Operations and Navigation Experience. Quite a mouthful. Its main purpose is to verify the stability of a special type of orbit between the Earth and the Moon called a Near-Rectilinear Halo Orbit, or NRHO. In short, this NRHO is essentially a highly elliptical orbit that is balanced between Earth and the Moon. No spacecraft has yet entered this type of orbit. So before putting a multi-billion-dollar space station in this location, NASA felt it would be a good idea to make sure the math checks out with regards to how stable the orbit is and how much fuel is actually needed to maintain this trajectory over time. What's also a good idea is for you to launch the like button into orbit. It helps with the YouTube algorithm and lets me know what you are all interested in. This small Capstone satellite is about the size of a microwave oven with a mass of about 25 kilograms. In September 2019, NASA awarded a contract to Advanced Space of Boulder, Colorado to manage the overall project. Tyvak Nanosatellite Systems of Irvine, California actually developed and built the spacecraft, while Stellar Exploration Incorporated worked on the propulsion system. In February 2020, NASA awarded Rocket Lab a $10 million contract to launch Capstone. The whole project is said to have cost the U.S. Space Agency about $30 million. While it was initially supposed to fly in 2021 from Virginia, the mission was delayed well into 2022, and the location changed to New Zealand, Rocket Lab's primary launch site. At 9:55 UTC, June 28, 2022, Rocket Lab's 17-meter tall two-stage Electron rocket lifted off from Launch Complex 1 in New Zealand.
4, 3, 2, 1. Confirm liftoff.
Less than 10 minutes later, the company's Photon upper stage with Capstone attached was placed into a parking orbit of roughly 220 kilometers. Over the next 6 days, the Photon upper stage gradually increased the high point of its orbit to about 1.3 million kilometers before releasing Capstone to fly on its own on July 6th. You might notice this is much farther than the 384,000 kilometer orbital altitude of the Moon. That's because Capstone was placed into a ballistic lunar transfer trajectory rather than a more standard Hohmann transfer orbit. All of that is because this spacecraft is going for fuel efficiency at the expense of time. Since this is a robotic mission, there isn't a huge rush to get the vehicle to the Moon like there is for human missions with limited life support. It took about 3 days for Apollo astronauts to reach the Moon, for example. Between July 6th and November 13th, Capstone will make various trajectory correction maneuvers before entering its intended orbit, the NRHO. However, just 1 day after being deployed by Photon, Capstone went silent. The spacecraft communicated with NASA's Deep Space Network as planned shortly after separation, but during its second communications check-in the next day, there was an anomaly. Mission operators were able to re-establish communications later that day, but it felt painfully long for many that saw Capstone as the inaugural Artemis mission. NASA later gave an explanation for what happened. During the commissioning phase of the mission, the Deep Space Network team noted inconsistent ranging data. While diagnosing this, the spacecraft operators sent an improperly formatted command that apparently made the radio inoperable. The spacecraft realized there was a problem, but it didn't reboot the system like it should have because there was a fault in the spacecraft's flight software. The software eventually cleared the fault and regained communications with the ground. NASA said the spacecraft continued to point its antenna toward Earth during the comms outage, all while keeping its solar array pointed toward the sun to keep its battery fully charged. It even used its onboard thrusters to desaturate or remove excess momentum from its reaction wheels, which are used to maintain its orientation. Once things were back in operation, the spacecraft operations team commanded Capstone to perform its first trajectory correction maneuver burn on its way to the Moon. When it ultimately reaches the Halo orbit on November 13th, the spacecraft will be in an orbit that flies about 1,600 kilometers above the lunar North Pole and about 70,000 kilometers above the lunar south pole. If you want to learn more about the particulars of what a near-rectilinear halo orbit means, I highly recommend you check out this explanatory video by Scott Manley. In a nutshell, this orbit allows the spacecraft to always be in view of Earth and is almost always in sunlight. It'll also take about 6 days for Capstone to fully circle the moon. Perhaps most importantly, for the future Lunar Gateway at least, is that this orbit spends most of its time above the southern hemisphere of the moon. It's also relatively easy to get down to low lunar orbit from this location. So when Artemis program astronauts are at the south pole of the moon, the Gateway can serve as a communications relay station, but it can also serve as a good rendezvous point for all sorts of hardware for crewed expedition. Capstone is designed to verify all the characteristics of this orbit so that there are no surprises when the first pieces of the Lunar Gateway arrive in 2025. But this CubeSat is also designed to test out a new spacecraft-to-spacecraft communications technique. Aboard the spacecraft is software called Cislunar Autonomous Positioning System, or CAPS. It is designed to communicate with the Lunar Reconnaissance Orbiter, which has been in low lunar orbit since 2009. CAPS will communicate with the Lunar Reconnaissance Orbiter and use data obtained from the comms link to determine its speed and distance relative to the two spacecraft and thus its position in space. NASA intends to evaluate Capstone's software to see how accurate the system is at figuring out its own location without having to rely exclusively on Earth-based tracking systems. All of this exciting stuff aside, NASA says Capstone provides a foundation for commercial support of lunar operations. It isn't just one rocket and one customer going to the moon this decade. It's a multitude of rockets, big and small, taking all sorts of hardware and people to the moon. It's also being done in a way that allows private companies to own their own systems, be they commercial launches, commercial resupply of the Lunar Gateway, landing system for humans, or even landing systems for small cargo and experiments. It also won't just be NASA that pays for moon missions. There will be multiple space agencies from around the world as well as private companies and organizations. As humanity moves further out, the same successful commercial models currently serving the International Space Station program and other low Earth orbit destinations will be brought out into deep space. An example of that is NASA's Commercial Lunar Payload Services program, which is expected to see several small commercially owned landers send payloads to the moon for NASA and other organizations. I just so happen to be working on a video about that, which you can check out right here when it's done. Otherwise, you can watch this video right here about NASA's Artemis plans. If you're enjoying this content, consider letting me know with a super thanks purchase. I'm trying to do this full time and any support makes it easier for me to spend more time making even more videos. No worries if you can't do that. The most important thing is for you to like and share this video and subscribe if you haven't already. Thanks again for watching, and until next time, ad Astra.